next talk by Dr. Nilesh Badwe, and he again have rich industrial experience before he came to academics actually, and that is how we have requested him to throw light. So Dr. Nilesh Badwe, he is assistant professor right now in the Department of Material Science Engineering at IIT Kanpur. Before that, he was with Intel Corporation USA as a materials technologist and a staff packaging R&D engineer. And he joined us in 2021 and currently leading industry partnership in India-wide efforts in semiconductor design, packaging. So is yours.
Thank you. Thank you, Professor Singh. So I'm going to talk about the main topic is same industry academia collaboration opportunities and challenges from semiconductors perspective. So what exactly we're doing? There are some efforts that are going on. But before I start with that, we heard a little background of my background from Professor Singh. I'll give slightly deeper insights into that. So we talk about industry academia collaboration, right? So I've been part of this collaboration for over 15 years at this point. Uh, when I started my PhD in Arizona State, a good part of my PhD project was funded by Intel. During this, during my PhD, I did 2 6-month long internships at Intel, which was located right very close to Arizona State University. So again, the what I'm trying to mention is having this industry and academia co-located. It helps with developing workforce that industry needs, and it also helps with developing technologies that are going to go into products. Later, I joined as a full-time engineer in Intel, where I worked as packaging R&D engineer. During that time, I I drove 4 university projects, industry academia projects. Two of them were through there is a consortium called Semiconductor Research Corporation. So what we were just discussing earlier, right? So similar to what Professor Singh mentioned, at CMU there is this multiple steel companies are coming together. This is a similar concept. There are large number of semiconductor companies who have come together. They have established the Semiconductor Research Corporation. It's a consortium. All of them put money in this consortium every year, and through that they fund multiple projects at different universities across the world, not just US but across the world. And the way these projects work is there are industry liaison on each of these projects. There is continuous collaboration going on, trying to make sure that whatever you are gaining out of these academic projects are of industry need. Academicians, through this I realized that yes, we do tend to have we have a tendency to go into slightly different directions, trying to uh, sometimes probably move away from what is needed for industry. So this continuous collaboration is necessary, and that's why there are industry liaison. Again, there are two other university projects that we funded directly through Intel, which I had driven. And then after that, as an assistant professor at IIT Kanpur, I've been driving semiconductor packaging R&D related activities in India, which are involving more than 50 major global semiconductor companies, and we have more than 50 faculties at this point from 13 different IITs plus IISc. And then I'm also leading some of the industry partnerships at this large scale R&D effort, which we call design semiconductor packaging and systems related R&D. Now, having said that, there has been resurgence of semiconductors in India. You must have heard that the government announced India Semiconductor Mission that was announced in December 2021. There is a there are geopolitical reasons. There are a lot more reasons beyond, even beyond that, uh, being like Atmanirbhar or Make in India and all of those. So through that, at this point, all the all the countries in the world, they have realized that you need to have your own semiconductor chip manufacturing, design related products. You cannot rely on others. So you must have seen. So there were few announcements over last 1 year. Government approved Micron's semiconductor packaging fab, testing and packaging facility that is being set up in Gujarat. uh, re- Recently, means there are companies like Sahasra, Keynes, CDIL who have set up their facilities. In Sahasra is based in Rajasthan, Keynes is based in Telangana, CDIL is also based in Telangana. So there are uh, several of these indigenous companies who are coming up with uh, related products, semiconductor related facilities in India. And then recently, very recently, when we are uh, at the end, I'll show, we had a large conference in Mohali. So on the very first day, cabinet approved three more chip making units that where investments are of the order of 1.26 lakh crore. So two of them are from Tata. One is semiconductor fab, one is semiconductor packaging facility, and then one from CG Power Renesas, that is also semiconductor facility. So there have been a lot of activities in semiconductor manufacturing in India, but some of the big names are still missing. We don't see people like Global Foundries, TSMC, Intels, and AMDs, and some of these major companies are still missing. So we started looking at what is needed to attract this global industry. There are few aspects. You need technology, local IP. If you develop technology in India, if you develop next generation, something that is that does not exist elsewhere in the world, if you develop any local IP, that can attract companies to come here and use that IP, manufacture in India. One very important aspect is skilled workforce, which includes process R&D engineers as well as technicians and operators. Then lot of times government incentives also help. That is something that government can do. And then infrastructure in terms of water supply, electricity, and so on. Out of all of these, right? These first two points, that is technology development, local IP development, and skilled workforce development. This is where academia can make a huge impact. This is something that it would be almost impossible to uh, generate new technology, new IP, as well as skilled workforce without help from academia. All of this is going to be feasible through different education, training, and R&D programs in at least leading institutes in India. So through that, what so all of these activities are being led by Professor Rao Tumala. He's emeritus faculty in Georgia Tech. He's a former IBM fellow. He worked in IBM for 25 years. After that, he was faculty in. He started a industry academia consortium, uh, packaging semiconductor packaging research center in Georgia Tech, that he ran for 30 years. He is already 80 plus, and he ran that for all this time. Right now, he's emeritus faculty and he's advisor to India Semiconductor Mission and the government of India. So, with his leadership, what we have done is we have started this 10-step large-scale efforts that was started in July 2022, where the process included forming a vision strategy based on some of the successful global models that we have across the world. Then form faculty teams at IITs, ISC, identifying what are the different product sectors, what are the different strategic research areas that we need to focus on. Going forward, acquiring knowledge from global experts, because when we talk about semiconductors, right, at least at this point, a lot of companies in India, there is skilled workforce in design, manufacturing, materials, process development. That is something that is fairly lacking. So we need to acquire knowledge from some of the global experts, identify global and domestic partner companies, and taking this to writing proposal for infrastructure, identifying right areas, right problem statements, and then creating this industry consortium, forming an industry consortium in India to focus on these R&D programs, to focus on skills development training programs, and followed by developing these next generation technologies and educating thousands of engineers. So through that, at this point we have what we are looking at is we are looking at this integrated systems packaging, creating these systems in India, where we have identified 12 different strategic research areas, and you can see there are names of different faculties who are leads of each of these areas. If you want to create any electronic product, right, all of these multidisciplinary aspects, different expertise, they have to come together to create the final system. So it includes all the way from electrical engineering, where you have to focus on designing aspects, to material science, to chemical engineering, to mechanical engineering. Multiple different aspects have to come together before you can form a system. All of these need to happen in four different areas that we have identified, which includes car, which is more towards like power electronics, computers, AI, communication, and IoT. Through that, beyond that, we currently have, as I mentioned, 13 14 different IITs, IISc. This is first line actually is focused on that. You can see all the major IITs are part of these efforts. We also have several NITs and local colleges, universities as part of our efforts. There are a lot more than this. I just couldn't fit all of those here. Few of those are represented here on the map of on India's map. And then at this point, we have more than 50 faculties from these major IITs and ISC who are focused on trying to get involved in this industry-centric R&D that we have started. In terms of industry, at this point, I guess it's probably not very well visible, or you may not be able to read it properly, but you can see we have 38 companies who are based in the US as part of our efforts. We have 12 companies from Europe, 8 from India, and 13 companies from Japan, Taiwan, Korea, from that region. Our focus is not only industry, but we also want to get involved different R&D centers who are focused on this semiconductor related research, who have developed these type of models, and successfully they have been running these for multiple years. We have more than 10 such models from US, 3 from Europe. uh, at this point there is no such model in India, so India it is 0. And then 3 from Asia, Southeast Asia region. Now, looking at all of this, right, our focus is how this industry and academia consortium, how what is going to be role of industry, how industry can collaborate with academia, what are the different areas. So for that, this is one of the important slides that I want to focus on, right? Uh, Three aspects that we have identified is research, education skills development, and then R&D infrastructure. How industry can collaborate with academia in these three different regions, right? So for research, there is going to be a lot of overlap between what Professor Jindal mentioned earlier in the previous talk and what I'm talking about. But in case of research, as you can see here, there can be industry can get involved as advisors in developing different R&D roadmaps. What should be how your R&D should progress over next 3 years versus 5 years versus 10 years. There can be co-advisors, or industry engineers can be co-advisors on PhD master projects. They can join industry consortium in these 12 different strategic research areas that we have identified. And then industry can identify eminent faculty scholars for R&D projects in all these different research areas. They should fund industry fellowships to graduate research assistants, and finally donate CSR money for R&D. There are already few of the companies like Google or Lamb Research. They are doing these initiatives. So there are different ways industry can partner in research. For education and skills development, the different areas that can include are advising in education and skills need. What are the skills that industry is really looking for. Sometimes we have seen that there is a big disconnect between what is being taught in academia versus what those engineers, once they graduate, once they join industry, what type of skills they need in order to be a successful, uh, in order to succeed, or in order to be successful in industrial setting. Industrial engineers can be visiting lecturers in relevant courses. They can mentor graduate students, offer internships and placements, train students in manufacturing, and assign engineers on as on-campus industry assignees for R&D and education. And industry can also have very big impact in developing this R&D infrastructure in academia, which would include advising on R&D infrastructure. What I see a lot of times, earlier Professor Ashutosh Sharma was also talking about, like, you can get large amount of money and then you buy this 30 crore toy, 25 crore toys, all this fancy equipment, right? So that is also something where industry can advise academia what type of equipment is something that would benefit in long run, because industry already has, most of the time, if not always, have far more experience in terms of running these equipment successfully, as well as utilizing them completely over a long period, and then uh, trying to ensure that there are proper skills development that align with industry need. Then donating funds for R&D infrastructure, it can be, this can be CSR or direct grants, and then donating equipment or in-kind donations. So all of these different aspects are where industry can actually collaborate with academia and then contribute into this industry academia collaboration. So what we are looking for is a three-way partnership model that we have developed for our semiconductor related research, semiconductor related R&D in India, which includes global industry, academia, and government, where role of the government is going to be to invest into R&D and manufacturing infrastructure for these COEs in 12 different research areas that we have identified. That includes setting up industry management system, and then funding 50% for R&D, and then 100% for education. Academia role is going to be to set up these industry COEs for R&D and workforce development on campuses, adopting industry centric culture that includes industry engineers on campus, industry prototype development. As I mentioned, there's going to be overlap, but this just tells that how important these aspects are in order to have a successful industry academia collaboration, and in order to ensure that whatever research that you are working on, or whatever R&D that you are performing, actually goes into product in next probably 5 to 10 years, not more than that, right? And then recognizing and rewarding faculties and students who are working on these industry centric R&D. And then the role of the industry is going to be to invest into these mini COEs as spokes with CSR funds. So government funding will set up these major COEs, and then we'll have this hub and spoke model, where the spokes, which are shorter versions of these larger COEs, where industry can fund those through their CSR money. They can fund R&D projects, assign industry engineers on campus, work with academics for research, and then work with ISRC, which is going to be India Semiconductor Research Center, that the government is soon going to announce, which is going to be co-located with Semiconductor Laboratory in Mohali. So working through ISRC for these integrated industry prototypes, where academia can work to develop, take any kind of concept to certain TRL level. Beyond that, there is going to be this Semiconductor Laboratory, India Semiconductor Research Center, who can, in collaboration with industry, take it to further higher TRL level, creating prototypes, and then at the end, industry can acquire those as for high volume manufacturing, ramp up and high volume manufacturing. So typical four phases for product development in semiconductors, they include system design architecture, research to explore new ideas and concepts, designing, demonstrating new systems, taking those to technology development, and finally high volume manufacturing. And typically what we see is there is a big valley between this research and technology development. Only 5% or even less than that crosses this valley. They cross this valley, taking going from research to technology development. And the reasons include there is typically very long cycle time, technology demonstration that can be done, but there are no industry prototypes, and disciplinary research and education, that is something that is missing. So our aim is to boost this to 30 to 50%, and the path to success includes involvement of industry from day one, where role of the industry and faculties can include keeping realistic expectations while defining the projects, avoiding overcommitment, clearly defined deliverables and timelines, for example, considering student exams or other aspects, and then a regular interaction which can be bi-weekly, at least like bi-weekly to monthly basis, right? That is typically, that doesn't happen with government funded projects, but this is something that is needed, if you want to have the successful industry academia consortium. And role of the institutes would be to encourage and recognize faculties engaging in this type of R&D, supporting on-campus industry engineers for R&D and educational engagement, and then setting up right infrastructure and training programs for industry, to protect industry IP. So just a closing. This is second last slide. We ran a very successful conference in Mohali, where we had more more than 350 people from across the globe, where more than 100 people from academia, more than 200 people from global, who are global industry experts and government dignitaries who were there, where this was entirely focused on how to enable this industry academia R&D program in India, where our day two, this was 3-day conference, day two was completely focused on presenting R&D proposals to to industry from academia, and obtaining feedback and starting collaboration between industry and academia. So this was all industry focused R&D. These were all industry focused R&D activities that are going to be focused on in semiconductor frame in India. So just to conclude, there are very there are two CSR initiatives that are already happening here at IIT Kanpur, where one of the companies, leading electronics manufacturing equipment supplier companies in India, Electronics, they have signed an MOU just a couple of months ago, where they are going to set up a center of excellence for electronics manufacturing and skills development here at IIT Kanpur campus. Another company, McDermid Alpha, who is again one of the largest electronics and semiconductor material supplier in the world, they also uh, signed an MOU, and they are providing their CSR grants to set up a thermal reliability lab again here on campus. So the focus of all of these are going to be on skills development, R&D, and then industry prototyping support. So this is where I'm going to conclude.